Hi everyone, welcome to Econ2's USA, and we'll be starting chapter 3 today. As we when we met last week, we finished chapter 2, and so I know you are comfortable with types of data, you are comfortable with how to calculate your probabilities, you are comfortable with frequencies and things like that. Today we'll be starting chapter 3, and in chapter 3 we'll be looking at measures of central tendency and measures of dispersion. So basically, we'll be looking at descriptive statistics. So the first one we'll look at will be measures of central tendency. That has to do with mean, median, and mode. Then secondly, we'll be looking at measures of variability. That includes variance, standard deviation, and range. We'll be looking at how the mean and standard deviation is used together. And then we wouldn't work on 3.4, but we'll move to 3.5, where we talk about measures of relative position and then measures of association between two variables. So let's begin by looking at measures of central tendency. What do we mean by that? So basically, when we talk about central tendency, it is a single value that's used to describe the center point of a data set. So it is, whenever you are able to use a single value to describe your whole data set, then we are talking about a measure of central tendency. So three measures of central tendency we'll be looking at. The first one is the mean, the second one is the median, and the third one is the mode. What is the mean? The mean is also called the average, and it is the most common measure of central tendency. I believe you've all heard about average. What's your average age? What's the average price of something? Average, right? So now, how do we calculate the average? So to calculate the average, we are going to add all the values in the data set and divide the result by the number of observations. So you are going to add all values in your data set and you divide it by the number of observations. So mathematically, how is the mean or the average written? So the symbol for your sample mean is X with a bar on top of it, and we say X bar. So sample size is your N, which is your small n, or sample size. So basically, and sample size is the number of data values. So the sample mean, which is your X bar, is equal to what? The sum. We are going to add each value of the data set and divide the sum of each value of data set by the number of data points. Is that okay? So we'll look at an example. Now, then we also have a population mean. So when we looked at the first one, we looked at the sample mean, the mean for a sample. Remember, we said the sample is what is part of the population. Population is everyone, but your sample is part of your population. To calculate your population mean, the symbol is what we call a mu, and it's written, it looks like a U, but we call it a mu. And to calculate that, to calculate my sample mean is going to be the sum of all your data points divided by your N, which is your sample size, okay, which is your size of the population. So let's look at an example on how the mean is calculated. To calculate the mean, as I said, we add each data point. So now we have a data set that is made up of 6.2, 7.1, 4.8, 9.0, 3.3. To estimate my sample mean, I'm going to add each of these data points and then divided by N. N is the number of data values. So let's count 1, 2, 3, 4, and 5. So because I have 5 data values, which is also the size of my sample, I'm going to divide the sum by 5, and that gives me my mean. There's also what we call a weighted mean. So it allows us to assign more weight to certain values and less weight to others. An example of weighted mean will be how you calculate your GPA. Okay, so you have your weights and then you have your GPA. So basically, if you are calculating your GPA, you have your A, B, C, D, right? And then how many A's do you have? How many B's do you have? How many C's do you have? It's the same thing. So in that case, what happens is you the value for each A or each letter grade you get, right? You are going to multiply by how many of those. So if I have 4 A's, right, and each A is 4 points, so it's going to be 4 times 4, correct? Good. So that's how we also do the weighted mean. So your frequency is basically the weights, and then your class or the number of days, or your grade level. If you are looking at GPA, that will be your X's. Now, okay, I wouldn't ask you so much questions about the weighted mean, so that's why we are not spending so much time on it. So what are the advantages and disadvantages of using a mean to summarize your data? First, it's very simple to calculate, right? And it summarizes the data with a single value. What are the disadvantages? One main disadvantage of using the mean is that we lose information if we have outliers, right? So, for example, if we are looking at the ages of students in a class, and let's say we have one student who is a very, very old student. Let's say this student is 70. So you have ages like 21, 23, 24, 25, and then you have the age of somebody who is 70. If you find the mean is going to show that the average age of the class is higher. It's very high. But in actual fact, this is high because we have an outlier, somebody whose age is a lot higher than the average age of all the other students. So that's one disadvantage of it. Also, when we use the mean, we lose some information about the original data. So the next thing we'll look at, or the next measure we'll look at, is the median. Median basically means what? The middle value. So median is the value in the data set for which half of the observations are higher and half of the observations are lower. Technically, it is the value in the middle of your data set. But first, in order for you to know the value in the middle, you have to rearrange your data set. So you rearrange your data set in an ascending order, with the lowest number first, and then the highest number will be the last. And then you find the middle point based on the number of data sets. So for example, if I have 6 data sets, then the middle will be what? It's going to be the number between the third value and the fourth value, correct? So let's look at an example. So an example is, in this case, we have a sample where n equals 7. So when n equals 7, then I know that my midpoint, right, half of 7 is 3.5. So basically, it's going to be the number in the 3.5 position, right? So 1, 2, 3. Then I have 1, 2, 3. So the number in the middle, correct? That's the number 28. That will be my median, is the number in the middle. So in this case, you round up, but basically the median is telling us the number in the middle of my data set. So one good thing about the median is that it's very sensitive. It's not sensitive to outliers. So we look at this example where you have an outlier which is like 5,000. It still doesn't change the position of what my median would be. So when we have odd numbers, right, odd number of data values, the median is always a middle value, right? So what happens if the number of data points we have is not odd, it's an even number? Then what do we do? When we have an even number of data points, then we are going to take the two numbers that are in the middle position, we add them and divide it by 2. So let's look at an example. So in this case, I have 145, 157, 170, 182, 204, and 209. So I realize that the middle is 3. So if I should draw a line in between these numbers, the line will be in between 170 and 182. To find my median, I'm going to take 170 and add it to 182 and divide it by 2, and that will be the median. So that's why we have 170 plus 182 divided by 2, and that gives me 176. The mode. What is the mode? Mode is basically the value that appears most often in a data set. So the value that appears most often in your data set is what we call the mode. If no data value repeats more than once, then we say that the mode does not exist. And then it's possible to have more than one value having the highest number. So you can have 2 or more values that tie for most frequent number of occurrence. So the mode is very useful when we have a categorical data. Okay. So let's look at the mode, an example of mode. So we have this data set. There's the number of children per family in a sample of 24 families. So basically we have 4 zeros, right? How many ones do we have? 1, 2, 3, 4, 5. We have 5 ones. How many 2s? 8. How many 3s? 4. How many 4s? 2. And how many 5s? 1. Which number occurs the most? We realize that the number 2 occurs the most. We had 8 of 2s. So that would be the mode. Also, we can express it in the form of a graph or a chart. And you see that in this case, Toyota, the number in parking lots, we have 7 for Toyota, and that will be our mode. So basically we've looked at the mean. So supposing there's an example, you should be able to identify the mean, the median, and the mode. Remember, to do median, you want to always rearrange your data from the smallest value to the biggest value and find the value in the middle. Mean, you are going to add everything and divide it by the number of observations. And mode, which number appears most often, and we realize that in this case is 100,000. So we can also show the mean and the mode in the form of a graph, or how it's distributed. So when the mean is equal to the mode, we have a symmetric looking shape. Okay, in this case the mean is equal to the mode. When the mean is less than, when the mean is equal to the median, when the mean is less than the median, then we realize that our data is left skewed. How do I know a data is left skewed? Because it looks like when you are going down a stairs, you are going down a stairs on the left side. That's the easiest way of explaining it. Most of your data sets are on the left. And then your data could also be right skewed. And that's when median is less than the mean. So once more, your shape, the shape of your data distribution is symmetric if the mean is equal to the median. It is left skewed if the mean is less than the median. And it is right skewed if the median is less than the mean. So we could also use Excel to calculate our mean, mode, and median. And as I said, most of these Excel programs, I want you to go through it yourself. And on Wednesday or Friday, I'll also go through some of these things in class to show you how you can use Excel to calculate all these things, okay? So let's look. So how do I know which measure of tendency is a better choice, or will be better to use? So remember, the mean is generally used unless we have outliers. If we have outliers, then the median is a better option. And then if we have categorical data, then the mode is the best option for us to use. So when do you use mean? You use mean when you don't have outliers. Median is best when you have outliers. And the mode is best when you have categorical data. So in this place, we have the advantages and disadvantages for the mean, the median, and the mode. Okay. The next thing I want to discuss is the measure of variability. So in this, we'll be looking at range, variance, and standard deviation. What do we mean by variability? Basically, it's talking about how much spread is present in the data. To what extent is our data spread? Okay. Remember, data is the information that we are collecting. Okay. So the first one we'll look at is range. Range is very simple. Range is what? Is the difference between the highest value and the lowest value. So range is the highest value minus the lowest value. So it's basically the difference between your highest value in the data set and the lowest value. Now, it's always important you arrange your data from the lowest number to the highest number. And this helps you to do your median. It helps you to even identify the range quickly. So in this example, my range is what? 13, because 13 is the highest value, minus 1, which is the lowest value, and that gives me 12. So my range is 12. What are the advantages of a range? It's easy to calculate and understand. However, the disadvantage is that it's only based on 2 numbers in the data set, and it's very sensitive to outliers. Variance measures the variability, or how much spread my data is from the mean. So I have the mean. To what extent is my data spread from the mean? And that is what we mean when we talk about variance. We are going to look at the variance in terms of the sample variance and population variance. Sample variance, variance for the sample. Population variance, variance for the population. To do that, the symbol for variance is S squared. Basically, it's like S with a 2 on top of it, and that is the symbol for sample variance. And it is X. X is each data point minus the mean. You already know how to calculate the mean, which is also called your average. We square it, and then we add it all, and we divide it by n minus 1. I know it looks like it's a lot, but I have posted handouts, and in this handout, I have done a step-by-step way of calculating everything: mean, mode, median, range, percentiles, and everything. So if you go back to the handout, you should be able to go through all these things again. So how do we calculate variance? So this is my data set. Step 1, I need to know what my n is. So my n is 8. How do I know? N is your sample size. How do I know my n is 8? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 data values, so my n is 8. My mean, how do I calculate mean? I'm going to add each number: 4 plus 6 plus 8 plus 9 plus 11 plus 12 plus 12 plus 18. And I divide it by 8. That gives me my sample mean. When I do that, I'll end up getting 10. So now how do I find my sample variance? My sample variance, I'm going to take each value. So I'm going to take 4, subtract it, 4 minus the mean, and square it. And then I add it to the next value, 6 minus the mean, and square it. I do the same for each value till 18. So the next step, now I put in 4 minus 10 squared plus 6 minus 10 squared plus 8 minus 10 squared to the end. I end up, then I divide it by n minus 1. It's important to know that you are not dividing by just n, but you are dividing by n minus 1. In this case, my n, which is the sample size, is 8. So 8 minus 1 is 7. So when I do that, I end up getting 18.571. So the variance measures the variability or spread of the data points around the mean. So the spread of this data point around the mean is 18.571. How do I find standard deviation? Now, the thing about variance is the variance is squared, right? And so if it's height squared, what does height squared mean? It's difficult to give it a meaning, right? So we end up using what we call the standard deviation, which is the square root of the variance. So square root of variance is your standard deviation. So basically you just find the square root of your variance, and that is what we call your standard deviation. So now we've calculated we calculated our variance. We got 18.571. We find the square root of this 18.571, which is 4.309, and that is what will give us our sample standard deviation. Now, supposing you don't want to go through the whole long process of calculating variance and standard deviation or sample variance, this is also a shorter way of doing it, which is your sum of x squared, each x value squared, you add it all, minus the sum of x, right, squared over n, all over n minus 1. So that's also another way of calculating it, and you should be able to, you won't get the same answer. What if we are not looking for sample variance but population variance? In order to do population variance, the main difference is that you don't divide by n minus 1, you divide by n, which is your population size. Remember, this mu is what? It's basically your mean, right? But this symbol mu means what? The mean for your population. So this gives me And then note that the symbol for population standard deviation is sigma squared. Okay, so we go through the same process again. Nothing changes. The main difference is that we don't divide by n minus 1. We divide by n to get our population standard deviation. So that's an example of how we calculate the population standard deviation. Now Excel also, you can also easily do this in Excel. Then, as I said, I'll be talking a lot more about doing some of these things in class. Okay, and yeah, in class. So now the next thing we want to look at is 3.3, which talks about how we use the mean and the standard deviation together. Now, we've looked at how to calculate your mean, how to calculate standard deviation. The next step is we want to use them together. Now, standard deviation is basically a common measure of consistency in business applications, right? So, but standard deviation will vary. The standard deviation is basically affected by the size of the mean. So you could have different mean sizes, but maybe the same standard deviation. So when sample means are different, comparing standard deviations is a little bit misleading. So now we'll talk about a concept known as the coefficient of variation. What is coefficient of variation? Simply, it is what? It is basically expressing your mean as a percentage of your standard deviation. So, coefficient, it measures the standard deviation in terms of its percentage of the mean. Okay, so your standard deviation in terms of its percentage to the mean. So standard deviation divided by the mean is what is going to give you your coefficient of variation. So a smaller coefficient of variation indicates more consistency within a set of data values. Think about it. You have your mean, right? And then your standard deviation is basically the spread around the mean. So if your coefficient of variation is small, that means that the spread is closer to the mean. If your coefficient of variation is big, that means it's really spread, it's very far away from the mean. So to do my coefficient of variation, it is what? It is my standard deviation, the sample standard deviation divided by what? My sample mean times 100. For population coefficient of variation is what? The population standard deviation divided by the population mean times 100. So, and this slide shows us an example of how coefficient of variation is calculated. So basically you have your standard deviation, which is 4, then you have your average price, which is 50, and then we multiply by 100. So the next concept we'll look at is what we call a z-score. The z-score identifies the number of standard deviation a particular value is from the mean of its distribution. So the z-score basically measures the number of standard deviations that a value is from the mean. So it's just a unit of measurement, okay? And how is it calculated is what we'll look at. So it's the z-score is basically, that's the unit, okay? So when the z-score is 0, it means the values are basically equal to the mean. When it's positive, it means that's the number of standard deviations above the mean, and then when it's negative, is the number of standard deviations below the mean. A data value z-score that's above positive 3 and below negative 3 is said to be an outlier. How do I calculate my z-score? Z-score basically is my x, that's the data point or data value of interest, minus the mean divided by standard deviation. So population z-score is x minus the population mean divided by the population standard deviation. And the sample z-score is x minus the sample mean divided by the sample standard deviation. This gives us an example of how our z-score is calculated. Okay. Now I'll talk about the empirical rule and Chebyshev, and we would end it for today, and when we meet in class we'll go through it again. So basically we have what is called the empirical rule, and we'll talk more about empirical rule when we get to chapters 6 and 7 going on. But according to the empirical rule, if a distribution follows a bell shape, symmetrical curves centered around the mean, we would expect that 68% of the data values fall within minus n plus 1, 95% of data values fall between minus 2 and plus 2, and 99.7% of the data values fall between minus 3 and positive 3. Again, empirical rule, which also means that says that if the data is bell-shaped, then 68% of data values fall within minus n plus 1, 95% of data values fall within minus 2 and plus 2, and 99.7% of data values fall between minus 3 and plus 3. Now we can also express the z-score in terms of x, and that's just by changing the places. So this is basically some mathematics, not so much, right? Because if your z is what? Your z is x minus the mean over standard deviation, then we can always solve for x to get this, right? Then I'd like to talk finally about Chebyshev. So we have a theorem called Chebyshev theorem, and it states that for any number z greater than 1, the percent of values that fall within the z standard deviations above and below the mean will be at least 1 minus 1 over z squared times 100. Now, Chebyshev applies regardless of the shape of the distribution. So if we use Chebyshev, right, supposing we put in the number 2 here, then I have 1 minus 1 over 2 squared, which will end up times 100, which will be 75%. If it's 3, 1 minus 1 over 3 squared, and that will be 89%, and then the 4 is 94%. So what do these percentages mean? So 75% means that at least 75% of the data values will fall within plus or minus 2 standard deviations. Then at least 89% of data values will fall within plus or minus 3 standard deviations, and at least 94% of data values must fall within 4 plus or minus 4 standard deviations. So we'll end here. I have posted 2 handouts. The first handout basically goes through everything. It talks about the mean, median, mode, and how to calculate it. And I have examples there which I have calculated, and I have some that I have labeled "try this." So what I want you to do is I want you to go to the handouts and try solving the problems. Do everything up to the z-score, and when we meet on Wednesday, we'll go through it. Thank you very much, and you have a very good day. Bye-bye.